Okay, let's talk about what is web application and what is web application development. We'll start with something we already know, and that's browsing the web. We know that to browse the web, we use a web browser and we can enter a URL, or we can simply click on a URL that's already embedded in a web page. And after we do that, the web browser will show us the web page that corresponds to that URL. What happens behind the scene is this. After we enter a URL, the browser will send that request to some server over on the internet, and the server will examine that request, and based on the request, pick the web page that is already stored on its local drive and then send that web page back to the browser, and the browser displays that web page. The data exchange between the browser and the server follows the protocol HTTP, which stands for Hypertext Transport Protocol. This is why the server is often called a HTTP server. The process conceptually, as you can see, is actually pretty simple, but there are a couple of things I'd like to clarify a little bit. The first is the so-called URL. A URL, as we know, identifies a certain web page that we want to see. And a URL actually has several components. The first component is a protocol component, and this defines, among other things, the data format exchanged between the client and the server. Later on in the course, we'll see exactly what's contained in a so-called HTTP request, and what's included in a HTTP response. And the format of a request is, and the response is defined in the HTTP protocol. Now, the second part of the URL is the host name, or sometimes you'll also see numbers like 127.0.0.1 or something like that, and those we know that are the so-called IP addresses. So both host name and IP addresses are a way to locate where the server is, and you can think of them as the name or address of the server. And that that part of the URL basically tells the browser where that request should be sent to. The third part of the URL is the port number. And since we already know the address of the server, why do we need the port number? That's because the address of the server simply identifies the computer, the physical computer of the server. But we know that on a physical computer, there could be multiple services running. For example, there could be a HTTP service running on the computer, but also a FTP service, an email service, a secure shell service, and so on. So in order to tell which service should receive the request, we have to identify the service, and that's typically done by using a number called port number. Most of the time, when we look at the URL, we don't see the port number. That doesn't mean the port number doesn't exist. What happens is that for each protocol, there's a default port number. For example, for the HTTP protocol, the default port number is 80. Now, if the HTTP service happens to be running at the 80 port number, then that number can be omitted, and the browser knows that by default it's going to look up the service at port number 80. However, sometimes the service is not running on the default port number. In this case, it's 8080 instead of 80. Then for any non-default port number, we have to specify the port number in the URL as well. The last part of the URL is often called the path. And this is a part of the URL that's utilized by the server to locate which web page or which file the browser is looking for. And for example, in this case, the path is cs320stu31/index.html, and based on that, the server knows that we are looking for a file called index.html under some folder cs320stu31. And so the server can grab this file and then send it back so the browser can display it. So this is how the web works, or in particular, how the so-called static web works. Static is in the sense that the web pages requested by the browsers are already created on the server, and they don't change regardless of who's requesting the page or when the page is requested. For example, if we look at the class homepage here, and if you can log on to my server, you can see that the class homepage is just a HTML file that's already created on my server, and this is in fact the class homepage, and I obviously created before the class. Right? And this is the so-called static web, and the web pages are pre-created, they don't change, and a web page request simply tells the server which file to retrieve, and that's it. Static web certainly works, and in fact it works quite efficiently. However, it cannot handle certain situations. For example, let's say that we want to search for something on Google. Let's say we search for, let's say, CS320. And of course, Google will perform some search and then return the results in a web page. Now, notice that Google cannot predict what query people will search on Google, right? In other words, this page cannot be pre-created because Google doesn't know somebody will search for the term CS320. In other words, this page has to be somehow dynamically generated after Google receive our query CS320. A similar example would be a shopping cart on an online retail website like Amazon. For example, this is my shopping cart page on Amazon, and there's one item here that's a PS3 wireless controller. Again, it's impossible for Amazon to predict what combinations of items and the quantity all of Amazon's customer will buy, right? And so it's impossible for Amazon to pre-create these shopping cart pages before we'll tell Amazon which products we want to order. So for those type of situations, we have to create so-called dynamic content, in the sense that it's impossible to pre-create those pages, and those pages have to be somehow generated on the fly. And if you look at the static web scenario, it certainly cannot handle those cases. So how do we produce dynamic content? Conceptually, it's actually pretty simple, much simpler than you would think. Now, this is how the static web works, right? We send a request and the server pick a pre-created file and then send it back. So how do we create dynamic content? Simple. All we need to do is replace those pre-created files with a program. We all know what a program is, right? A program is simply a piece of code that takes some input and produces some output. Although the code of the program doesn't change, but based on different input, the program can produce different output. And that's basically the gist of the dynamic content on the web, or the gist of web applications. A web application, by and large, is simply a program that takes HTTP request as input and then produce HTTP response and output. And it's as simple as that. Now, with that said, there's some terminology we need to explain a little. And first of all, the term application server. Depending on what book or what documentation, white paper you read, there are different definitions of web servers, application servers. Fundamentally, application server is really just an HTTP server that can run a program on the server side. So it has to speak HTTP. In other words, it has to be able to receive HTTP requests and then send back HTTP response. And also it has to be able to run a program on the server. Thus, they name application server. Right? And if you compare these two pictures, the HTTP server basically serves static content, and the application server will serve dynamic content by invoke some programs, or in other words, applications on the user input, which are essentially the HTTP requests. In Java web programming terminology, you would also sometimes see the term servlet container. A servlet container is basically an application server that is capable of running the server-side program called Java servlets. Later on, we'll see what Java servlets looks like, but by and large, a servlet container is simply an application server. Now, also note that although in this class mostly we'll deal with web applications that runs on the server, but in practice, oftentimes a so-called web application often have two components: the server-side components that runs on the server, and then a client-side components that runs within the browser. The client-side components typically deals with the user interface part of the application, how to get user input, how to display the responses in a nice looking way, and so on. And the server side typically deals with processing, accessing data in databases, and so on and so forth. So in this class, we focus mostly on server-side programming, and we don't have enough time to deal with client-side programming. But client-side programming, in some, you are probably going to learn those in some other classes that deals with things like HTML, CSS, JavaScript, and so on. So for server-side technologies, there are many of them. In the good old days, the server-side programs were implemented using the programming language C, or later on Perl, in the so-called CGI, or the Common Gateway Interface scripts. And these days, the mainstream server-side technologies are based on Java, or ASP.NET, or PHP. And then there are some newer languages like Ruby and Python, and corresponding web technologies and frameworks based on these languages. In this class, one question that I got quite often is, among all these different technologies, which one do we want to choose, or which one is the best, right? And the answer is that there's no best technology. If there is one, then we would be already using that one, and no other technology would exist. The fact that we have so many technologies these days kind of speaks to the fact that none of them is the best. With that said, you can also see that the flip side of it is everything is good. So for example, Google used mainly Java, and MSN, of course, uses ASP.NET, and Yahoo uses PHP in its external websites, and also Java in its internal infrastructures. So when people ask me which one is the best, I often tell them that if something is good enough for Google, Microsoft, or Yahoo, it's probably good enough for you. So in terms of choosing a technology, oftentimes the main criteria is not the technical capabilities of those technologies, because they are all equally capable. You can say that. Say that. But there are some other concerns, like what languages you are already familiar with, what languages your development team is comfortable with, and so on. So those are more important concerns oftentimes will choose a web technology. Now, because our curriculum is heavily committed in Java, you've been learning Java in many previous classes. So for this class, we are going to use Java-based technologies, in particular the so-called Java servlets and JSP. The good news is that all of these technologies share lots of common concepts and techniques and methodologies. So once you learn one technology, usually it's very easy to pick up others. Just use a different language, but everything else is pretty much the same. Now, these are the server-side technologies that creates programs that runs on the server. There are also client-side technologies that you use to produce programs or pages that runs within your browser. And for example, you would have HTML, and you would have cascading style sheets, you would have JavaScript, Java applets, and you would have also the so-called rich internet application technologies like Flex, Flash, Silverlight, JavaFX, and so on and so forth. Now, due to time constraints, we are not going to cover these technologies in this class. Although, if you later on want to become a web developer that do this as a living, then you'll have to learn quite a bit of these technologies as well, in particular JavaScript, HTML, and CSS. But that's for something for another class. So now that you know what is a web application and what is web application development, let's get back to the question, why do we have to learn to write web applications? What's the importance of this that we have to spend a class on this? Now, to answer that question, all you need is to look at some of the most successful companies these days: Google, Microsoft, Facebook, Amazon, Netflix, and so on. If you look at these companies, you can see that all of them rely heavily on web applications, and their web applications can typically be categorized into several categories. For example, some of these companies take traditional businesses like retail, like video renting to the web, so that they can reach to a much larger audience. These companies like Amazon and Netflix are thriving these days, while there are more traditional competitors like Best Buy and Blockbuster are either dying or already dead. And that shows you the power of the web. And there's also currently the trend to convert traditional desktop applications to web applications, like, for example, TurboTax. It used to be that every year you have to go to a store, spend $40 to buy a CD, install it, and then you do your tax using TurboTax. But now you can just go online and then register an account on TurboTax, and you can do it that way without having to buy a CD every year. And even the killer app on desktop, Microsoft Office, now is moving to the web. And not only it makes it more available and easier to use, but it also allows features that are not possible in traditional desktop versions, like a real-time collaboration document that can only be achieved when you use the web version of Office. And the last but not least, and is last but I guess is even most important, is web application also opens up lots of new opportunities, as showcased by Facebook, Twitter, YouTube, and those companies and businesses that created new ways for people to connect with each other, to communicate with each other, to provide new media outlet channels for people to express them, and so on and so forth. So all of this shows you the power of the web and the power of web applications. And lots of new technologies claim that they change our life, but web really did change how we live our life. The trend, I believe, will continue, and that's because web applications have some inherent advantages over desktop applications. In the good old days, it used to be that if you create some software, you first have to create a bunch of CDs, and then you wrap those CD up in nice looking boxes. You ship those boxes to stores like Best Buy, CompUSE, and then they put your boxes on their shelves. So even before a consumer lay their eyes on your product, there's lots of upfront cost for publishing, for distribution, shipping, and so on. But if you create web applications, the cost is very low to reach your potential customer base. All you need to do is put your application on a web server, and then all of a sudden people all over the world can use it. And you can potentially reach very large user base, and at the same time, the administration of the application is centralized, so your customers don't have to install the software, your customer don't have to maintain the software. It's very easy to do data backup. It's very easy to keep the application update. The application is available anytime, anywhere, and nobody can steal your application and resell it. So all these are very, very important advantages over traditional desktop applications. Of course, there are some disadvantages of web applications. For example, you do need to have a network connection in order to use it, and web applications these days tend to have user interfaces that are less pretty or less responsive than their desktop counterparts. But as broadband network become more and more available, and as technologies like Ajax and RIA help improving the user interface of web applications, the disadvantages of web applications are diminishing, and the advantages remain the same. So it's not a stretch to say that web applications will remain very, very important in years to come, and knowing how to develop web applications is going to be a very important skill in your skill set as a computer science student.